Welcome to Math 104, section 4.6, dividing polynomials. So we're going to work on three things today. We're going to start by dividing a polynomial by a monomial, and then a polynomial by a polynomial, and then we're going to divide polynomial function using function notation. So we're going to start off by dividing a polynomial by a monomial, and we're going to use this property, a plus b over c. We can take this and split it up into two individual fractions, a over c plus b over c. So let's try this out with some actual numbers to see if this works. So I'm going to write a fraction up here, 30 over 3. And I can rewrite 30 as 9 plus 21, still over 3. All I did is break up the 30 into 9 and 21. All right, now let's use this property. Now I can break this up into two separate fractions, 9 over 3 plus 21 over 3. Well, 9 over 3 is 3, and 21 over 3 is 7. Add them together and we get 10. 30 over 3, 10. So it works. Now let's see how it works when we start introducing some polynomials. We're going to divide 4x plus 8 over 2 by 2. All right, so we take this, we're going to split it up into two individual fractions using this property. We'll have 4x over 2 and 8 over 2. Then we can simplify each one. 4 over 2 is 2, so that's 2x. 8 over 2 is 4. So we get 2x plus 4. Your turn number 1. So we got 12x plus 15 over 6. First fraction will be 12x over 6. Keep the same sign, plus 15 over 6. And I'll simplify. 12 over 6 is 2, so that's 2x. And 15 is 6, that reduces to 5 halves. 2x plus 5 halves. All right, next up, we're going to divide a trinomial by a number. So we got 10x squared minus 25x plus 35 all over 5. So we have three terms up top, so this property doesn't just apply to polynomials with two terms. This can extend to any number of terms. So since we have three terms on top, we'll split this up into three different fractions. 10x squared over 5 minus 25x over 5 plus 35 over 5. All right, now we can simplify each of these individually. 10 over 5 is 2, so we got 2x squared. 25 over 5 is 5, so minus 5x. Notice I'm keeping the same signs here, positive, negative, positive, positive, negative, positive, positive, negative, and this one will be positive, plus 7. 2x squared minus 5x plus 7. Your turn number 2. All right, so we're going to split this up into three fractions. So we got 16x squared over 8 plus 48x over 8 minus 24 over 8. And that gives us 16 divided by 8 is 2, so 2x squared plus 48 over 8 is 6, so that's 6x, and 24 over 8 is 3, so minus 3. 2x squared plus 6x minus 3. All right, so we've been dividing by just numbers. Now we're going to have a monomial with some variable parts at the bottom. All right, so we're going to divide by 4x to the third. So that means we're going to have to apply the quotient property of exponents. So we'll split it up into 3 separate fractions, 4x to the fourth over 4x to the third, minus, keep the sign, 7x to the third over 4x to the third, plus 12x squared over 4x to the third. All right, now we're going to divide number by number, and then we'll apply the properties of exponents to the variables. 4 over 4 is 1, x to the fourth over x to the third, subtract the exponents to get x. All right, keep same sign, minus. Now, 7 divided by 4, we cannot reduce that, so we're going to keep that fraction 7/4. And x to the third over x to the third, those cancel, so the x's are gone. So just 7 over 4 in the middle. Now over here, we've got 12 over 4, that's 3. X squared over x to the third, 2 minus 3 is -1, so x to the -1 power. And then we want to, in our final answer, we want to get rid of any negative exponents, so the final answer is x minus 7/4 plus 3 on top, and the negative exponent, bring that down to the denominator and make it positive, so 3 over x. Your turn, number 3. So we'll split this up into 3 separate fractions. Now divide each one separately. 14 divided by 7 is 2. X to the fifth divided by x to the third. Subtract the exponents to get 2, so that is 2x squared. Middle term, 28 divided by 7 is 4, so plus 4. X to the third over x to the third, those cancel, so those are gone. Last term, minus, on the same sign, 5 over 7. And then x squared over x to the third, that gives us x to the -1 power, which ends up in the denominator. So 2x squared plus 4 minus 5 over 7x. Make sure you write it so that the x is very clearly in the denominator. All right, next example, we've got more than one variable. So for each part, we'll just take them one at a time. All right, so there's our 3 separate fractions. Now we can do the division. Got 6 divided by 1 is 6. A squared over a to the third, that's a to the -1 power. B to the fourth over b to the fourth, those cancel. All right, 9. Got a to the third over a to the third, those cancel. B to the third over b to the fourth, subtract those exponents to get b to the -1 power. Finally, we got 4 over here. A to the third over a to the third, those cancel. B to the fourth over b to the fourth, those cancel. So those are all gone. So now all I have to do is take those variables to the negative power and move them to the denominator. So that is 6 over a minus 9 over b plus 4. And that brings us to your turn, number 4. All right, there's our three individual fractions. Now let's divide each one separately. We got -3 divided by 1, so -3. A to the fourth over a to the third, that's a to the first power. B to the fourth over b to the fourth, those cancel. So -3a plus 7. A squared over a to the third, that is a to the -1. B to the third over b to the fourth, that is b to the -1. And over here, we have a to the third over a to the third, those cancel. B to the fourth, those cancel. What do we have left over there? 0? No. 1. Remember, when we cancel, we leave behind a 1. It's a common mistake I see. Everything cancels, we just forget about it and leave a blank or put a 0 there. Don't do that. When we cancel, anything divided by itself is 1. All right, now all I have to do is rewrite that middle term. So we got -3a plus 7 over ab plus 1. Now we're going to move on to dividing polynomials by polynomials. We're going to do polynomial division. So this is very similar to long division, just using regular numbers. Now, if you've forgotten how to do long division with regular numbers, you should go review that right now. Because we're going to use almost the exact same general strategy with some very important differences. So for example, we're going to divide 2x squared plus 17x plus 30 by x plus 6. So what we're dividing by goes out here. We're dividing into goes underneath the division symbol. All right. So first thing we want to do with polynomial division is we're going to eliminate each term one at a time. So that means we have to match this term. So the question is, what do we have to multiply x by to get 2x squared? And you get that by taking this and dividing by x. So 2x squared divided by x is 2x. So that's our multiplier, 2x. And that multiplier goes up top. All right, now we distribute 2x into the binomial x plus 6. So make sure you multiply this by both terms. So 2x times x is 2x squared. And notice that matches here. If you don't get a match here, you've done something wrong. So go back and change this until you get a match. All right, now 2x times 6 is 12x. All right, so there's the result of distribution. Now we're going to subtract this. Put in parentheses, subtraction. So we want to subtract both of these terms. So 2x squared minus 2x squared, those cancel. That's what should happen every time. The leftmost term should go away. 17x minus 12x is 5x. All right, now just like with regular long division with numbers, now we bring down, or we would normally bring down the next number, now we're going to bring down the next term. So 5x plus 30. All right, now we just start the game all over again. Now we need to match 5x instead of 2x squared. All right, so what do we need to multiply x by? And we're just do the left one. Just forget the plus 6 for now. We're just worried about the x. What do we need to multiply x by to get 5x? Well, that's 5. So the multiplier goes up top. Now we distribute. 5 times x is 5x. All right, we got our match here, so we're on the right track. And then 5 plus 6 is 30. Oh, we got a match there as well. So when you subtract, you get 0. So the remainder is 0. That means this binomial divided evenly into that polynomial. And there's the answer. Now, with any kind of a polynomial division like this, it's very easy to make mistakes. So we should always check our work by taking our answer and multiplying by the divisor. And we're going to FOIL these. 2x times x is 2x squared. Right? We got 2x times 6 is 12x. 5 times x is 5x. Add those together and we get 17x. And then 6 times 5 is 30. So you try to be able to multiply those together and get what is underneath the division symbol. All right. Perform this algorithm with your turn number 5. Our first match we need is 6x squared. We're going to multiply 3x by something to get 6x squared. All right, how do we figure that out? We divide. 6x squared divided by 3x is 2x. So there's our multiplier, 2x. And we take 2x and distribute into this polynomial. So that is 6x squared plus 8x. Put parentheses around it and subtract. 6x squared minus 6x squared is 0. Good. 17 minus 8 is 9. So we got 9x. Bring down the next term, plus 12. All right, now we need to match 9x. So 3x times something is 9x. That is 3. So put your multiplier up here. Now we'll distribute 3 into this binomial. 3 times 3x is 9x. 3 times 4 is 12. And we got a match of the whole thing. So we subtract, get 0. We have 0 remainder. So that is the answer right there, 2x plus 3. And if we go ahead and FOIL these things, we do indeed get 6x squared plus 17x plus 12. But not all of these are going to divide evenly. So we need to be able to handle remainders. So we're going to divide x plus 2 into x squared plus 3x minus 8. All right, first match we need is x squared. So what do we multiply x by to get x squared? X. All right, now distribute. X times x is x squared. All right, we got our match here, so that's great. X times 2 is 2x. And subtract. 3x minus 2x is x, so we bring down the next term and we get x minus 8. All right, now we need to match x. What do we need to multiply x by to get x? Well, that's 1. So plus 1 up here, and 1 times this binomial is x plus 2. And we'll subtract. X minus x is 0. Negative 8 minus 2 is negative 10. So it didn't work out evenly this time. Now, there's no way we can find anything to multiply x by to get negative 10. So that means we're done. We can't go any farther. So that's our remainder. So what do we do with that remainder? All right, we take our answer here, x plus 1. Take the remainder, keep the sign on the remainder. 10 goes on top, and the divisor goes on the bottom, x plus 2. All right, so I see people make mistakes with this. Sometimes put the 10 over this thing. Sometimes just put the 10 on the end. Make sure you put the 10 over the divisor. All right, now we should still be able to check this. Let's try it. I'm going to take our answer, x plus 1 minus 10 over x plus 2, and multiply by the divisor. All right, so there's the operation we need to do. Now what I'm going to do is just break this up into two parts. I'm going to do x plus 2 times x plus 1, and then I'm going to do x plus 2 times this fraction. All right, so FOIL here, x squared plus 3x plus 2. And now look at what happens here. If I multiply this by this fraction, we have x plus 2 on top, x plus 2 on the bottom. Those cancel, we just get minus 10. And that's what should happen every time. So that's why we put that divisor on the bottom, so you can cancel that. Just add on that negative 10. So that gives us x squared plus 3x minus 8. Right back where we started. Your turn, number 6. All right, we first match 2x squared, so we multiply 2x by x. Distributing in, we get 2x squared, and x times 1 is x. Right, so we can subtract that. 0 here, 5x minus x is 4x. I'll bring down the next term, plus 7. All right, now we need to match 4x. So we'll multiply 2x by 2 to get 4x. So plus 2 up here, that gives us 4x plus 2. Subtract them and get 5. All right, so the degree here is lower than the degree of the leftmost term here, so we're done. That's our remainder. So the answer then is x plus 2 plus, we have a positive value, so it's plus 5 over the divisor, 2x plus 1. All right, now we'll check. So I'll multiply everything by the divisor. Foiling here, that's 2x squared plus x plus 4x plus 2. And here, 2x plus 1 times 5 over 2x plus 1. The 2x plus 1's cancel, leaving just plus 5 on the end. So that gives us 2x squared plus 5x plus 7. So that checks. Now, all the ones we've seen so far have had polynomials where each of the powers, they just go down by 1. So we have second power, first power, 0 power. But what if that doesn't happen? What if we have like a missing term in there? So next up, we're going to handle that. And we're going to handle it with a placeholder. So we are dividing x minus 1 into x to the third. Now notice there is no x squared term. So we're going to make one so that we have a placeholder up here. So we'll just put 0x squared. Coefficient is 0. And we've got a spot for the x squared place, and that's going to be very helpful. Plus 2x minus 3. And this just makes everything line up much easier. All right, so now we need to match x to the third power. So we multiply x by x squared. So x squared goes on top, and we distribute. X squared times x is x to the third. X squared times negative 1 is negative x squared. Now notice we put that 0x squared term. Now we have something there that we can subtract that from. So it's helpful to keep things organized. Okay, x third minus x third, that's 0. And we have 0 minus negative 1, So that's positive x squared here. And now we'll bring down the next term, plus 2x. Now we have to match x squared, so multiply by x up here. Distributing, x times x is x squared. And x times negative 1 is negative x. Subtract, those go away. 2x minus negative x is 2x plus x, or 3x. So we got 3x minus 3. All right, now we need to match 3x, so we'll multiply this by 3. Plus 3 up here, and there's 3x minus 3. Those match, so we get 0 remainder. And if you go ahead and do the polynomial multiplication here, you will in fact get x to the third plus 2x minus 3. And that brings us to your turn number 7. Make sure you put a placeholder in there. All right, no x terms, so plus 0x, there's a placeholder, minus 18. All right, got to match x to the third first. This is 7. All right, so that's going to be x squared up top. Now we'll distribute. X squared times x is x to the third. X squared times 3 is 3x squared. All right, subtract. And we get 2x squared here. Bring down the 0x. All right, got our placeholder there. So now we need to match 2x squared. So multiply x by 2x. So we got 2x up here. Distribute. 2x squared plus 6x. All right, those go away. 0 minus 6 is negative 6x. Bring down the negative 18. All right, now we need to match negative 6x, so minus 6 here. Negative 6x minus 18. Subtract, and we get 0. 0 remainder, so that one divides evenly. So there's the answer. We also may have a missing term in the divisor. And it's helpful to use placeholders there as well. So for next example, the divisor is x squared plus 3. So I'm going to write that as x squared plus 0x plus 3. Alright, so now we need to match x to the fourth using this leftmost term here. We need to multiply this by x squared. Alright, x squared times x squared is x to the fourth. X squared times 0x, that gives us 0x to the third here. So we got our placeholder here to do the subtraction. And x squared times 3 plus 3x squared. Alright, now we can subtract x to the fourth minus x to the fourth is 0. Negative 4 minus 0, that stays negative 4. X to the third. And over here we got 5x squared minus 3x squared. And that gives us 2x squared. Bring down the next term, negative 3x. Make sure you always have the same number of terms here as you have over here so that all the columns line up with each other. So next up we need to match negative 4x to the third. So if we divide this by x squared, that gives us negative 4x. So that's what we want to multiply by. Negative 4x. Alright, distributing. Negative 4x to the third plus 0x squared minus 12x. Alright, those match, those go away. 2 minus 0, that's 2x squared. And negative 3 minus negative 12 is negative 3 plus 12, so that is 9x. Now I'll bring down the last term, plus 2. All right, one more to do. We need to match 2x squared. So I'm going to put 2 up here, distribute the 2 in here. All right, 2x squared minus 2x squared, those go away. 9 minus 0, we get 9x here. 2 minus 6 is negative 4. All right, now the degree here of 1 is lower than the degree here. So that means we're done. There's no way we can multiply something by x squared to get x. So that's the remainder. So here's our answer, x squared minus 4x plus 2. The remainder, it's okay if it's a binomial, that's still just going to go on top of the fraction. And the bottom of fraction is this, but we can leave out the placeholder. Just go x squared plus 3. Your turn, number 8. So we're going to start by matching 3x to the 4th power. So I put my placeholder there, 0x. Alright, so to match this, do 3x to the 4th divided by x squared, that gives us 3x squared. So 3x squared is the multiplier. Distributing that into here, we got 3x to the 4th plus 0x to the 3rd minus 15x squared. Now we'll subtract. 3x to the 4th minus 3x to the 4th, that's 0. 5 minus 0 is 5. So we get 5x to the 3rd here. And then negative 8 minus negative 15, that's negative 8 plus 15, which is positive 7. X squared. All right, bring down the next term, minus 13x. Now we need to match 5x to the 3rd power. So we're going to multiply x squared by 5x. 5x to the 3rd plus 0x squared minus 25x. All right, those go away. 7 minus 0 is 7, so we got 7x squared. And 13 minus negative 25 is 13 plus 25, or 12. So 12x goes here. Bring down 2. There's our last term to bring down. Now we need to match 7x squared, so we're going to multiply x squared by 7. 7 goes up here. Now distribute. 7 in, that gives us 7x squared plus 0x minus 35. Now we'll subtract. Those go away. 12 minus 0 is 12, so we get 12x there. 2 minus negative 35 is 2 plus 35, or 37. So we get 12x plus 37. So our final answer then is 3x squared plus 5x plus 7 plus a remainder, 12x plus 37 over the divisor x squared divided by 5. Now notice every time we try to divide in, we've been able to find a whole number multiplier. It doesn't always happen that way. So next example, I'm going to divide 4x plus 8 into this polynomial. Alright, so I need to match 8x to the third power. So multiply 4x by 2x squared. Alright, distribute that in. That gives us 8x to the third plus 16x squared. Alright, subtract those. 8x to the thirds, those go away. 21 minus 16 is 5. So we've got 5x squared minus 2x, and bring down the next term. Okay, now I need to multiply 4x by something to get 5x squared. Well, there's no whole number I can multiply 4 by to get 5. It's going to have to be a fraction. Alright, so I want to end up with a 5, so that's going to have to be in the numerator. And I want to get rid of the 4, so that has to go in the denominator so that they cancel. So I want to multiply 4 times 5/4, the 4's cancel, leaving a 5. So this is called a fractional coefficient. So if you cannot find a number, a whole number, to multiply by to match this, you're going to have to use a fraction. Alright, so, and we need an x there, so 5/4 x. Alright, now we're going to distribute 5/4 x into here. So 5/4 x times 4x is 5x squared. And then 5/4 x times 8 is 10x plus 10x. Now subtracting, that gives us negative 12x, and bring down negative 24. Alright, now I need to match negative 12x, so I'll multiply 4x by negative 3. And then distribute, negative 12x minus 24, those all match, 0 remainder. So it divides evenly. So our final answer is 2x squared plus 5/4 x minus 3. Your turn, number 9. Alright, we need to match 2x to the third power. So we're going to multiply 2x by x squared. Alright, x squared distributed in here, that gives us 2x to the third and 2x squared. Alright, now we can distribute. Now we can subtract, so 7 minus 2 is 5, so we get 5x squared, and then bring down the 9x. Right, now we need to match 5x squared. So what do we multiply 2x by to get 5x squared? Right, there are no whole numbers we can multiply by, so here's where the fraction is going to come in. I'm going to have to multiply 2 by 5 halves. Right, the number we want goes on top, the number we're trying to get rid of goes on the bottom. So 5 halves x. So now I'm going to distribute this in. So that gives us 5x squared. And 5x over 2 times 2, the 2's cancel, and that leaves us just with 5x. Subtracting now, we got 4x, bring down the 3, 4x plus 3. All right, now we need to match 4x, so we got a 2 up here, distribute. 4x plus 4, subtract, and get negative 1. So negative 1 is the remainder, and we get x squared plus 5x over 2 plus 2. All right, you've got a minus 1, so minus here, and 1 over 2x plus 2. All right, now we're going to divide using polynomial functions. So the same operation, just using function notation. So here's our last property. Function notation, we got f divided by g, the combined function of x, equals f of x over g of x. So just like with the other properties, if we evaluate them both individually and then divide, we get the same answer as if we divide the function first and then plug in a value. All right. All right, now we've got this function g of x that's in the denominator. Whenever you have anything in the denominator, we always have to worry about division by 0. And we're going to exclude any values that would produce 0 from the domain. So we cannot plug any value for x. It's going to give us 0 down here. All right, so first example, we're going to define f of x to be 8x to the third minus 27. And g of x, define that to be 2x minus 3. All right, now we're going to do f over g of x. All right, so now we're going to do polynomial division just like before. Just we're starting off the problem with a different notation. That's the only difference. And then excluding values from the domain. Okay, so we've got 2x minus 3 into x, 8x to the third minus 27. Now we've got two placeholders for this one. We do not have an x squared term, and we don't have an x term. So I'm going to put in 0x squared and 0x. So those are two placeholders. Minus 27. All right, let's do the division. You're going to match 8x to the third, so that means we need to multiply by 4x squared. All right, subtract. Those go away. 0 minus negative 12 is positive 12, so we get 12x squared. And I'm going to bring down the next one, 0x. Now we need to match 12x squared, so I'll multiply 2x by 6x. All right, 12x squared minus 18x. Subtracting, we get positive 18x. Bring down the 27. All right, now we need to match 18, so multiply by 9. 18x minus 7, those match, and we got 4x squared plus 6x plus 9. And we just have to make sure. All right, here's our answer. And then let's look at this denominator now, 2x minus 3. Let's see what values will give us 0 here. Set this equal to 0 and solve. All right, 2x minus 3 equals 0. Solve this and we get x equals 3 halves. So that means x cannot equal 3 halves. So you just got to include that little detail there. Your turn, number 10. All right, so there's a polynomial with a couple of placeholders. I need to match 27x to the third, so I'll multiply 3x by 9x squared. Distributing, 27x to the third plus 36x squared. Subtracting, get negative 36x squared. I'll bring down the next term, 0x. All right, now we need to match 36, so that's going to be negative 12. So minus 12x. Minus 48x. And subtracting a negative, that's positive, so that's 48x plus 64. All right, now we need to match 48x, so we're going to multiply 3 by 16. That gives us 48x plus 64, so we got a match there. Subtract and we get 0, so no remainder. So our answer is 9x squared minus 12x plus 16. And if we set 3x plus 4 equals 0, x will equal negative 4/3. So x cannot equal negative 4/3. All right, now we're going to look at function notation evaluated at a specific value of x. Make sure you're comfortable with function notation, because any of these problems, operations with polynomials, can and will be presented in either regular notation or function notation. All right, so we're going to do f of x equals x squared minus 9. And g of x equals 2x. Okay, so f over g of x equals, we can divide these two out, so we got x squared minus 9 over 2x. We have a monomial on the bottom, so we do not need to do polynomial division. We'll just split this up into x squared over 2x minus 9 over 2x. And that equals, cancel 1x here, so we get x over 2 minus, and that cannot be simplified, so that stays 9 over 2x. All right, so now we want to find the value of this. Oh, and of course we have to have our little disclaimer here. X cannot be 0, so we'd have division by 0. All right, so now we're going to do this, f of g, and find it for the value x equals 2. So plug in 2 for every value of x. So that gives us 2 over 2 here minus 9 over 2 times 2. So 2 over 2 is 1 minus 9/4. And then we can get a common denominator. 4/4 minus 9/4 equals negative 5/4. That brings us to your turn number 10. Now for this one, g of x, denominator is a binomial, so we do have to do polynomial division here. So we're going to divide x minus 3 into x to the third plus 0x squared plus 0x minus 9. All right, you're going to match x to the third first. So that is an x squared up top. Distributing, it gives us x to the third minus 3x squared. Subtracting, those go away. 0 minus negative 3 is positive 3. So 3x squared. Now I'll bring down the 0x. Now we need to match 3x squared, so we're going to multiply x by 3x. And that gives us 3x squared minus 9x. All right, 0 minus negative 9 is positive 9. You get a positive 9x here. All right, now we need to match 9x, so we're going to multiply x by 9. 9 goes up here. 9 times x is 9x. And 9 times negative 3 is negative 27. All right, now we'll subtract. 9x's go away. Negative 9 minus negative 27 is negative 9 plus 27, so that is 18. So 18 is the remainder. So that gives us x squared plus 3x plus 9 plus 18 over x minus 3. So that is f over g of x is that. Okay, now we want f over g evaluated at 1. So we need to plug in 1 for every value of x here. So f over g at 1, and yes, it works even with remainders. So we're going to get 1 squared plus 3 times 1 plus 9 plus 18 over 1 minus 3. All right, so that equals 1 squared is 1 plus 3 times 1, so that's 3 plus 9 plus 18 over negative 2. All right, combine all these, 9, 10, 11, 12, 13, plus 18 over negative 2 is negative 9. Add those together, and we get 4. So f over g evaluated at 1 is 4. All right, that is it for today, and that wraps up this unit. Everybody have a great day.